Hi, in this video I want to talk about using rings as a physical modeling synthesizer using the sympathetic string model. Now, if you look in the video, you'll see two synthesizers, elements and rings. They're both physical modeling synthesizers. A physical modeling synthesizer often has two components. Something to put energy into the system, in this case in elements, this, and something that will ring or resonate, hence the name rings. So in elements, this section here is the resonator, and rings is essentially just a resonator. So elements has got an exciter, which just puts energy into the system, and a resonator. Rings just has the resonator, but if you don't plug anything in, it will supply its own excitation waveform of whatever type it happens to be. But what I like to do is use rings and build my own excitation section, which is all of this stuff here. Okay, so let's have a look at the basic rings. My rings is actually an nRings, so it's a rings clone, and that's very small. I find those knob placings are too close together, so what I like to do is I like to use my pressure points to control it. So what we've got is we've got the bottom row of my pressure points is controlling the brightness, and the top row is controlling the shape control, which in the sympathetic string mode puts it through different pitches, octaves and fifths. So what I can do also is I have the middle row controlling the envelope shape of the excitation waveform, which is what this math is doing here, which we'll talk about in a minute. So because I've got 8 different pressure points, I have actually got 8 presets. So you can play them both together like that. Now, let's have a look at how we make the excitation waveform. So this comes from this combination of a noise generator and this filter being processed in its amplitude by this VCA, which is controlled by math. So that is taking some of the role in elements that would happen over here. Now, I can change the characteristics of a filter. Currently, it's completely open. I've got it in low pass mode, but the frequency is way up. So it gets more dull. Let's add some resonance. Let's change it to a bandpass filter. See, what I'm going to do, I'm going to change the envelope. So instead of it being a decay envelope, it's just an attack and decay with a sustain. So let's talk about these envelopes a little bit. I've got 2 channels of math. This one, channel 4, provides an attack and decay envelope, so there's no sustain. Channel 1 has a slow attack, or however fast the attack is, a sustain forever until I release the key, and then a release. So I can control them by the mixer on math there, and because they're going through this VCA, this is actually sweeping the amplitude of the math signal, so that's changing the amplitude of our excitation signal. But this other channel of the VCA is being used for velocity control. At the moment, I've got velocity. Let's put this on. So I've got control over the velocity. If I don't want that, I turn the CV off and I just up the gain. And now I have no velocity control, which for sustained waveforms I find more useful. So I'm going to turn that off. Now let's go back to our filter, which is controlling our excitation signal. I'm changing the shape of the rings. So we've got different strings being emphasized. But got a lot. Yeah, we've got a lot of noise and a lot of high frequencies being emphasized. Sometimes I have this tracking the keyboard as well, but I haven't done that today. Okay, so we've now got our articulator, well not our articulator, our exciter going into our resonator. We've got controls over it. What I also find useful is to have some modulation. So let's get a sound. You can add vibrato, which can be useful. So I've taken my LFO, which is Dixie running in LFO mode, and I'm using this Optomix to control the amount of vibrato. So this channel is doing that. I've also got our colored noise generator coming out of here, and it is controlling the pitch as well. I'm going to turn the vibrato off. So now I'm using the colored noise to modulate the pitch. And I've also got, in the auxiliary input, an extra tuning control, which I've got coming into that channel 2 of math. So that just gives me a way of tuning it. And of course, if I bump it, it'll go completely out of tune. Okay, so we've now got virtually everything. The last thing I want to show is that what we can do with our noise input, we can also modulate the frequency with noise, different noise. Anyway, these are all ways we can animate the signal. Now, we're hearing this completely dry. There is no delay, no reverb, no EQ, no nothing. It is completely what is coming out of the synthesizer. Currently, I'm running 2 different channels out. That means it'll be alternating between the left side and the right side. Often, if I was using them, I might not have them fully panned hard left and right, or I may even mix them together. But there are many options of being able to quickly shape the sound in real time when we're using rings in its sympathetic string mode. And what I'm going to show now is a quick video that I did. I was in Vietnam at Ha Long Bay. I was on a cruise ship and we were going along, and I recorded a flute improvisation, and at the end the anchor went down. When I came home, I created an accompaniment which was all done with this patch. So hope you like it.